Ever pondered why an apple falls straight down from a tree and not sideways or upwards? Or why does a roller coaster always end up at the same place it started, regardless of the twists and turns? These everyday phenomena are governed by a fundamental concept in physics known as conservative forces. Imagine walking your dog in a park. You start from a point, take a stroll around, and finally return to the starting point. In physics terms, you've just completed a closed loop. The energy you expended on this walk is akin to the work done by a conservative force. If you took a different path, say, you decided to walk by the lake or around the playground, in the end you'd still return to your starting point. The energy you've spent, despite the different routes, remains the same. That's the power of conservative forces. They're called conservative because they conserve mechanical energy. The work done by these forces only depends on the initial and final positions of the object acted upon. The path you choose doesn't matter. Whether it's a straight line, a zigzag, or a scenic route around the lake, the work done remains the same. Now let's take a moment to think about the forces we encounter in our everyday lives. The gravitational force, the magnetic force, and the electric force are all examples of conservative forces. They have a unique characteristic. The total work done by these forces around any closed loop is always zero. This characteristic enables the definition of potential energy for these forces. So, to summarize, conservative forces are a fundamental concept in physics that describes forces whose work is determined solely by the initial and final positions of the object they act upon. They conserve mechanical energy, and the work they do is independent of the path taken. Gravitational, electric, and magnetic forces are common examples of conservative forces. Understanding conservative forces not only helps us make sense of the world around us, but also forms the basis for many technological advancements. From designing roller coasters to understanding the orbits of planets, the concept of conservative forces plays an integral role. So next time you see an apple fall from a tree or ride a roller coaster, remember it's all thanks to conservative forces.